This is Erzuo. I work with the ads ranking team of Pinterest. Today, I'd like to share how we apply deep learning techniques to solve the multi-objective and the multi-data source problems in Pinterest ads. The billion-dollar ad business at Pinterest relies heavily on machine learning models to predict ads engagement rates quickly and accurately. Several problems remain critical and challenging to us. The first issue is that we have two primary ad products, standard and shopping. There are so many distinctions between those two in creatives, features, and user behaviors. Learning them simultaneously proved to be a non-trivial problem to us. The second one is that we have multiple optimization goals. For example, we want to optimize click-throughs, of course. There are other objectives that are equally important, like the save to board and offset conversions, which are critical for user experience and partner values. Is it even possible to learn all of them with one model? That would be an interesting problem to solve. Last but not least, we want to ensure that the predictions are calibrated because this is important for pricing. Before we jump into our solutions, I want to give an introduction to Pinterest AutoML, our in-house end-to-end machine learning framework. It has some awesome features. Firstly, it enables automatic feature engineering. This allows the deep neural network to learn directly from raw features and saves a lot of time of the machine learning engineers. Secondly, it provides powerful and flexible model architectures. Then, let's take a look at the model structure. An AutoML model is composed of several layers. The representation layer applies feature transforms to the input features, such as squashing, clipping, hashing, and normalization. As simple as they seem to be, they are surprisingly efficient in terms of feature engineering. The summarization layer groups the signals that are from the same feature family and learns the common embeddings between them. For example, you can learn the common embedding of category vectors of both user and an ad. The latent cross layer is a multiplicative layer. It learns the high degree interactions and forces explicit feature crossing. The fully connected layer is the classic multi-layer perception. Our machine learning solutions are built on top of AutoML. For the optimization of multiple objectives, we adopted multitask learning. Thanks to the deep neural network, we are able to learn multiple objectives simultaneously if we define the loss functions like this. And the multi-data source problem is even trickier. As I mentioned, the two data sources, standard and shopping, are so distinct that they tend to mess up each other if we learn them directly via a single deep neural network. We thus developed the shared bottom and the multi-tower structure. The shared bottom captures the common knowledge of all the data sources, and the multi-tower structure is effective in isolating the interference between training examples from the different data sources. The next innovation we proposed was a lightweight calibration layer. We created a plus scaling model to calibrate the predictions of DNNs. The calibration layer only contains a small set of features, such as the contextual features, ad format features, and the user features. This makes the calibration layer lean and fast to converge. We are able to update the calibration layer hourly to catch up the latest trends in our ads, while the DNN models are updated daily. As a result, we can see that our approaches did a great job. The multi-tower structure performs much better than the single tower solutions on offline evaluation. We can see that both AUC and log loss have non-trivial gains. And for the lightweight calibration model, it is able to reduce the calibration error by as much as 50%. Both of the developments result in significant gains in user engagement and top-line business metrics during the online A/B test. That concludes my presentation, and I'm open to questions.